What's good everyone, my name is Ev and welcome back for another video. And today is a special day again. In today's video we will react to some scientific things. The video is called How Skin Color Works. So they're gonna explain how skin color works. But before we get into the video, make sure to like, subscribe, because it helps a lot. Help me reach 100 subscribers before the end of the year. That would be fantastic. Make sure to check in the description all the links, and we're gonna get right into the video.
Skin color or skin pigment is something that our students have typically loved learning about. And most of our students will tell us, yes, genetics plays a huge role in skin color or skin pigment, and even that the sun can influence how much pigment the skin produces. But what layer specifically is responsible for the skin pigment? And more importantly, what are some of those differences that you might see inside the skin with somebody with lighter skin, all the way up to darker skin and everywhere in between? That answer might surprise you. And you may have noticed that those with darker skin have a greater difference in the pigment of the palm of their hand and the dorsal aspect of their hand. We'll talk about why that is and even go into some sun damage and things of that nature, as well as think about this. If I were to remove the skin from a body, yes, I do understand that sounds a little bit morbid, but we are a cadaver lab. But if I were to line up all of the bodies we have in our lab in a row,
Some people do that already.
remove the skin and have you look at those bodies, you couldn't tell me the difference between each body, meaning which body had which pigment of skin prior to the removal of the skin. Kind of interesting to think about. So let's jump right into this. So for us to fully appreciate skin color or skin pigment, we have to review the skin a little bit. The skin belongs to a system called the integumentary system, or the integument, and it's comprised of three main layers. So let's take a look at the cadaver dissection that we have here. This is a skin graft from the mid-back, and you can see
Damn, no, let's not say that. That's not cool.
this top layer, or the superficial layer of the integument, is referred to as the epidermis. Epi just means upon, dermis means
We're here
skin.
to learn. So
Now, what's really cool is
let's
if I
not
flip up
critique
the edge
anything.
here, you might think that the majority of this edge is the epidermis, but the majority of that edge that I'm running the probe on is actually the next layer down. It's that top paper thin layer right there that actually makes up the epidermis, so pretty thin. And when I say paper thin, the majority of the epidermis throughout the whole body is about 0.1 to 0.15 millimeters in thickness, pretty close to the thickness of a sheet of paper. Now, there are some other areas of the epidermis that are much thicker, like on the palms or on the soles of the feet. That can range from 0.6 up to 4.5 millimeters in thickness. Now, you may not think 4.5 millimeters is that thick, but remember, the majority of the body is 0.1 to 0.15. And if you compare 0.15 millimeters up to 4.5 millimeters, that's a 30-fold increase in thickness on the palms and the soles, which we are definitely going to discuss later on in this video. But if we come back to this dissection here, the next layer down that I hinted to was the dermis, or the dermal tissue, and that's the majority of the thickness of this dissection here. The dermis is a dense connective tissue that provides strength from like tensile forces, like the skin being pulled apart. It can resist being pulled apart. Also has hair follicles pushing down into it, glands, and even blood vessels. But the next layer down, if I flip this over, is referred to as the hypodermis, or the subcutaneous layer. Now, we've removed most of the hypodermis and the subcutaneous layer from these other areas, but you can see that yellowy tissue where we kept it in certain areas. And the hypodermis is made out of an adipose tissue. And adipose
I'm gonna look how they do to remove skin like that, because that's way too clean.
can range from relatively thin all the way up to inches thick.
I've never
Adipose
thought
layer, or
I've never thought it could be possible to like remove somebody's skin like this. I mean, it doesn't sound easy, but yeah, it doesn't sound easy at all. But like, how did they do that? Anyway, let's continue
or
the
that
video.
subcutaneous layer, also known as the hypodermis, because anatomists love naming things. It is for energy storage and insulation. And I just want to be clear here. The true skin is actually the epidermis and the dermis. We add the hypodermis to complete the whole integumentary system. So it's kind of like the epidermis and dermis, the skin is a subset of the whole integument. But what are we here for? We want to talk about where the pigment comes from. What's interesting is if we talk about tattoos, the majority of tattoo ink or pigment gets deposited into the dermis. And we have a pretty cool tattoo video that we'll link that at the end of the video if you want to take a look at that later. But the majority of the ink, like I mentioned, or pigment from tattooing is in the dermal tissue. But there's a big difference from depositing artificial ink or pigment versus creating your own pigment. And how we create our pigment, or where we create it, is specifically in that epidermis, which is crazy to think about again because the majority of it is only 0.1 to 0.15 millimeters in thickness. So all the color that I shouldn't say all, but the majority of our skin pigment, some of it is influenced by like blood supply and things like that. But the pigment itself, just in that top paper thin layer that we call the epidermis. So obviously we're gonna have to go a little bit deeper into the epidermis to fully understand pigment formation or pigment production. Yeah. So if we zoomed into that top edge of the epidermis here, again, it would look paper thin to the naked eye, but as we zoomed in, we would see that it is cell upon cell stacked on top of each other, or multiple cell layers thick. The majority of the cells
Oh, let's go back
on
a
top
little.
each other, or multiple cell layers thick. The majority of the cells of the epidermis, or at least 90% of the cells that make up the epidermis, are referred to as keratinocytes. Cyte meaning cell, keratin because they produce a protective or strong protein called keratin. That keratin helps bind the cells together and in turn helps protect us on the top layer from friction and abrasion. But the keratinocytes don't produce the pigment. That's going to be the job of another cell. Now remember, we're really zooming into this epidermis, and this epidermis can be further subdivided, or what we'll see is there's sublayers. The bottom row of cells of the epidermis is referred to as the stratum basale. And again, the majority of that's going to have keratinocytes, but it will have, interspersed between the keratinocytes, another cell that's important called the melanocyte. Cyte meaning cell, but because they produce melanin, they get called melanocytes. And melanin is that pigment that gives the color to the skin.
Yeah,
now,
that we know
because
that.
the melanocytes interact with the basale, the bottom sublayer here, and the next sublayer above, I have to mention some key points with those sublayers. The stratum basale, those keratinocytes, are mitotically active, meaning they constantly divide. And a cell will divide and get pushed up to another layer. And when the next cell is copied, the cell that was here then moves up and a new one comes in its place. And eventually this continues to happen so that one cell that was at one point in the stratum basale will eventually make it all the way to the top of your epidermis and flake off and contribute to the dust of your house. Now, the melanocytes are going to be doing something to those cells in the basal layer, but they'll also interact with the cells in the sublayer above called the stratum spinosum. Now, the stratum basale was only one cell layer thick, but the stratum spinosum is up to 8 to 10 cell layers thick. Now, some of you are geeky anatomists and want to know why things get named the way they did. Now, these cells in the spinosum, when they were looked at under the microscope, they would shrink down. But because they were attached to all the other surrounding keratinocytes, even though the majority of the cell would shrink down, the places where it was still attached to the other cells would be kind of pulled out, attaching to each other, and it looked like little spines on the outside of the cell membrane, hence the name. But those melanocytes, let's really dive into these things now. These are really cool cells that we already know produce melanin. They have these cool things called cytoplasmic extensions, or they look like little arms that are coming out from them that are kind of just extensions of their cell membrane, that they can contact up to 30 different keratinocytes, some of those in the stratum basale and some of those in the stratum spinosum. And what they're going to do is deposit melanin into those keratinocytes, and that will give each keratinocyte a color or a pigment. Now, how much melanin is deposited in there will dictate how dark the cell gets. Now, what's crazy to think about is that 8% of the epidermis, or 8% of the epidermal cells, are melanocytes, regardless of your skin pigment. So if you're lighter skin or darker skin, you have about the same number of melanocytes. It's just with darker skin, those melanocytes are more active and produce more melanin kind of at that baseline rate. And what I mean by a baseline rate is all of us kind of have our baseline pigment or color without UV stimulation or stimulation from the sun. And that just gives us kind of, like I said, our baseline skin color. But if we go out in the sun, let's pretend all of us go on this little beach gathering together and we're out frolicking in the sun, you know, swimming in the water, whatever we like to do on the beach, and that sun is coming down. that will stimulate the melanocytes to produce even more melanin. So all the cells that are in contact with those melanocytes are getting extra melanin in it. Because most of us have probably heard melanin is protective. It's protecting our keratinocytes, specifically the nucleus and the DNA inside the nucleus, from DNA damage and potential mutation. And so more UV light exposure, more potential for DNA damage. So melanocytes are like, let's produce more and protect. Now, we know that in general, people with darker pigment.
The body is fascinating to me. Every science video that I watch, I learned a little bit of something, even though we went all to school, we learned some stuff from school, but we don't go deep like that at school. We don't go deep into things like that at school. So it's really interesting to hear a little bit more about different. But yeah, let's continue the video.
Are less at risk for things like skin cancer and UV damage. They're just more protective compared to somebody who has lighter skin. And when we talk about getting a tan, whether you think it's a good thing or a bad thing, there's plenty of evidence that shows fair-skinned people getting exposed to UV light are at greater risk for skin cancer. But why don't you maintain the tan is a question people will get. Well, we all went home from our beach trip and weren't stimulated by the sun as much. Now, we only had that UV stimulation for that day, and the cells in that stratum spinosum and stratum basale only got extra melanin deposited. So when the basale creates more cells for us, it pushes those cells that are darker pigment from the tan, if you will, and eventually those darker keratinocytes will flake off. And so for those of you who like to be tan all the time, you know that you have to constantly get UV stimulation to maintain that tan. For those of you who are afraid of the sun, like myself, you try to tend to avoid that overstimulation of the melanocytes by caking on, SPF 50. So what about the differences in pigment on the palms of the hand and the soles of the feet? Well, the answer to that lies in the additional sublayers of the epidermis. Now remember, we already talked about two sublayers of the epidermis, the stratum basale and the stratum spinosum. We're going to add a couple of more to help us understand these differences in the palms and the soles. But let me mention one thing about the epidermis. The epidermis is an avascular tissue, meaning it doesn't have a blood supply. There's no room for blood vessels to penetrate between those cells. Typically, we like cells to have a blood supply in order for them to stay alive. But the dermis underneath the epidermis, where the epidermis plops down on top of, does have a blood supply. So those cells in the bottom, like the cells of the stratum basale, those are the most mitotically active. They're close enough to blood that they can continue to divide and get those nutrients. But as the cells get pushed up further and further away from the blood, they start to flatten out. And that's exactly what happens in our next sublayer that we're going to talk about. This is called the stratum granulosum. And yes, those cells are flattening out, but they're also releasing these little granules full of lipids. And these granules, you can kind of think of these little sacs filled of lipids and oils. And they're releasing them outside of themselves. So essentially coating themselves in oil. Now, why would these cells do that? Well, if we think about the mortal enemy of oil, that is water. So we're creating this waterproofing barrier in the epidermis so water cannot pass freely in and out of the epidermis. Kind of cool, but admittedly, there's no difference between the palms and the soles and everywhere else in the body. They just have this typical granulosum in those areas. But when we get to the top layer, called the stratum corneum, those cells have fully flattened out and are completely dead. You'll have a stratum corneum everywhere in your body. And in some areas, it can be a couple cell layers thick, but in the palms and in the soles, it can be up to 50 cell layers thick, contributing to that extra thickness here. Now think about light trying to penetrate through more cell layers, and then you may have noticed one other thing. I didn't mention another sublayer called the stratum lucidum. The stratum lucidum is in between the granulosum and the corneum. The reason I didn't mention it initially is because you only find that on the palms of the hand and the soles of the feet and nowhere else throughout the body. Now, lucidum refers to like being lucid or transparent or full of light, and again, producing an additional thickness to the palms and the soles. So you're adding all this extra thickness and makes it harder for light to penetrate through. And it kind of makes sense when you look at your palms or the soles of your feet. Now, a couple other things to consider. Most of us aren't exposing our palms to the sun very often either. Just the natural position of how we hold our hands they don't get exposed quite as much, and definitely the soles, as you're just walking down on the ground a lot of the time, don't get nearly as much sun exposure. That's the same essentially with everybody with lighter pigmented skin all the way up to darker. The difference is those with darker pigments, it's just more noticeable because they have that darker pigment everywhere else, so that change is a little bit more dramatic or more noticeable. Now, like I mentioned at the beginning of the video, I have to touch a little bit on sun damage, and that's mostly because of our aesthetic students, because whenever they come into the lab, one of the first things they point out on this particular skin graph is they point to all these little areas and they're like, what? Sun damage? And as you can see, they're pointing out those areas of hyperpigmentation or other spots that a lot of us will refer to as freckles. Now, there are two types of freckles. One is called aphelides and the other is called lentiginous. Aphelides, that funny name there, is more of a inherited type of freckle that you'll see in really light-skinned people and appears to just be a genetic thing. Now, lentiginous is more of a sun damage or a sunburn freckle, as some people will refer to it as. And that's because of overexposure to the sun and potential sun damage. And these areas where you're seeing those freckles or those lentiginous, that is a buildup of melanin or little patches of melanin in those areas, again, because of overexposure to the sun. Now, I always say to people, yes, the evidence is pretty clear that light-skinned people are more at risk for developing skin disorders and skin cancer because of UV exposure, but we'll let everybody decide how much sunscreen you want to lube up with. You know, I typically recommend throw the 50 on and go play in the water and frolic on the beach. As always, thanks for watching, everyone. If you want to support...
That was a great video. Yeah, I really learned a lot. And if you also learned, make sure to let me know in the comment section. But yeah, that was a great video. So if any of y'all that's funny. If anybody knows somebody that's racist, send him this link so he's gonna know what it really means to have like the lighter skin versus the darker skin. Just, yeah, it is what it is. We are the same, just the color that differs. But anyway, intelligent people know that already. So that's it for this video. Make sure you like, comment, subscribe. Don't forget to check the links in the description also. And yeah, hope y'all have a great night, because yeah, it's nighttime here. So hope y'all have a great time, great day if you're watching me during the day. And yeah, catch you in the next one.